All right, here's the back side of the notes. So once again, when we divide, we keep change flip. Those of us that are going into pre-cal need to up our vocabulary, and we multiply by the reciprocal. The first thing that you should do is rewrite the problem and change that divide to multiply. So now my x plus 2 is in the numerator, and 3x minus 3 is in the denominator. Once you do that, always look for a GCF first, and then we're going to factor. This top left trinomial, I need factors of 3 that add up to -4. And I know that's -3 and -1. So you factor x minus 3, x, that's a -1, and then x plus 2. When we multiply straight across, this whole thing is one big numerator. In the denominator, I have an x plus 1. And then here I have a GCF of 3. So I'm going to factor out a 3 and then get x minus 1 left over. This is everything fully factored. Now you can start canceling. My x minus 1's cancel, and that is it. So my final answer is x minus 3, x plus 2 over 3, x plus 1. Can't do anything more than that. I'm going to move on to number 10, and I'm going to show you something new. This is called a complex fraction. So I have a fraction. This is a big fraction bar and another fraction on bottom. So we're this big, bold fraction bar. I'm going to rewrite this with a traditional divide sign, and then it's going to look like number 9 up above. So this rewritten is x minus 8 over x squared plus x divided by x squared minus 5x minus 24 over x to the third. Now, I'm going to fix this first before I move forward. I'm going to multiply by the reciprocal. So this first fraction doesn't change. And the second one, I'm going to flip it. All right. Now, some parts you're going to need to find a GCF, and then other things you're going to need to factor. This is one giant numerator. Do not multiply and distribute ever. So I have one factor of x minus 8. I have another factor of x to the third. This denominator, I have an x squared plus x. There is a GCF. They each have an x in common. So I'm going to have to factor that out. And when I do, I get an x plus 1. This last trinomial, I need factors of -24 that add to -5, which are -8 and 3. So this factors as x minus 8 and x plus 3. Now that everything is fully factored, now you can go canceling. The x minus 8 cancels with the x minus 8 on bottom. This x to the third and this x, those are monomials and they can cancel each other out now. So there's an invisible 1 on that x on bottom, and I'm going to subtract. So that leaves me with an x to the second on top, x plus 1, x plus 3 on bottom. So the only real thing that you need to know and remember on this one is the big fraction bar in the middle of these two. We're just going to replace this with a traditional division sign. And then we're going to do our keep, change, flip. All right, number 11. Here is my big division sign that separates the numerator from the denominator. So I'm going to rewrite this as x squared minus 4 divided by x squared plus 3x plus 2. There's my big division bar, so that's where my divide sign goes. And then I'm going to rewrite the denominator as x squared minus 5x plus 6 divided by x cubed plus x squared. All right, let's do our keep, change, flip, or multiply by the reciprocal. So I have x squared minus 4 over x squared plus 3x plus 2 times x cubed plus x squared over x squared minus 5x plus 6. All right, now let's go factoring. This x squared minus 4, that is the difference of squares, and that is going to factor as x plus 2, x minus 2, x to the third plus x to the second. There is a GCF of x squared right there. So I'm factoring out my x squared, and then what's left over? X plus 1. Denominator. What are my factors? Or you can make an ACB chart. What are my factors of 2 that add to 3? And that would just be 1 and 2. So this denominator factors as x plus 1, x plus 2. And then this trinomial, I need factors of positive 6 that add up to negative 5. Well, the only way that's going to happen is if they're both negative. And so negative 2 times negative 3 equals positive 6, and that adds up to negative 5. So that factors as x minus 2, x minus 3. Now everything is fully factored. Now I can cancel. All right, do I see an x plus 2? Yep, those cancel. My x minus 2's cancel. My x plus 1's cancel out. And I'm left with x to the second over x minus 3. This is my good final answer. You are absolutely positively not allowed to cancel this x to the second with this x, because this x minus 3, this is a factor that's working as one whole unit together. And so that's why that is my good final answer. Let me know if you have any questions. Go try some problems on your homework. Thanks.